7 nails, 1 shelf. Make it fair. Lift it, and the left 3 ease off. But now the right side is furious. Tilt it for them, and the middle starts to howl. Every fix breaks somebody. You cannot please them all. So stop trying. Let go. It swings past, comes back, and settles. Nobody is happy. Everybody is exactly as unhappy as they have to be. Who solved that? This is least squares. The physics. Welcome to the workshop. Every nail on this wall is a measurement. Your data, pinned exactly where it fell. The rod is your model, and it can do only 2 things. Lift and tilt. 2 dials. Between each nail and the rod runs a rubber band. Ideal bands, pull twice as far, feel twice the force. And for now, each band runs along a thin vertical guide wire, so it can only pull straight up or straight down. Remember that choice. It matters later. Now hold one stretched band in your mind and ask what it's storing. What does a stretched band cost? Energy. Stretch an ideal band, and it stores elastic energy. 1/2 K times the stretch, squared. Hear that? Nobody chose to square the error here. Physics squares it for you. Add up every band on the wall, and the whole shelf carries 1 number. The total elastic energy. Seen from the space of measurements, that same number was the sum of squared residuals. That was a whole other film. This one lives here. So the shelf is strained, and every band is pulling. A stretch system wants one thing: to shed energy. It doesn't need instructions. It doesn't need a formula. It needs your hand to get out of the way. Let go. And let the wall decide. Where does it want to be? Picture every pose the shelf could strike, every lift, every tilt. Each pose is a point, and its height is the energy it would cost. Together they form a landscape. And for ideal bands, it is a single smooth valley. 1 bowl. No false bottoms. Letting go is just rolling downhill. And slow, damped rolling downhill has another name: gradient descent. The shelf settles where the ground goes flat, where the gradient of the energy is 0. Machine learning climbs down this valley step by step. The shelf just falls. But what holds it still at the bottom? Balance. At rest, the vertical pulls cancel. The sum of the residuals is 0. And the twists cancel too. The sum of x times residual is 0. Force balance. Torque balance. 2 conditions for 2 dials. Write those 2 balance conditions down, and you are holding the normal equations. X transpose x, beta hat, equals x transpose y. The shelf isn't solving them. The shelf is them. And because the valley is a perfect bowl, you don't have to watch the fall at all. You can compute the floor directly. 1 shot. The closed form. Not every band deserves to be equal. By a nail you trust, hang a thick, stiff band. It pulls hard. By a foggy measurement, hang a thin, slack one. It barely tugs. Same wall. Same shelf. But now, some nails have more of a say. Which nails get a say? The stiff ones. Stiffness is trust. Set each band's stiffness to 1 divided by that nail's variance, and the shelf settles into weighted least squares. Foggy nails whisper. Clean nails pull. Now the troublemaker. Hammer 1 nail far from the crowd. Its energy grows like the square of the miss, but its pull grows only linearly. And that is still enough to wrench the whole rod toward it. 1 nail, bending everything. So change the band itself. A cord with constant tension, the same pull, no matter the stretch. Now the far nail tugs no harder than a near one, and the rod stops chasing. That fit is L1, the median. Last film, you changed the ruler. Here, you change the band. Why won't it settle? Line up your two dials so they nearly do the same thing, and the valley stops being a bowl. It stretches into a long, soft trough. One direction stiff, one direction almost flat. The shelf drops into the groove fast, and then wanders, drifts, takes its time. Along that groove, the floor is nearly level, so the coefficients are barely pinned down. The ratio of stiff to soft is the condition number, kappa. The bigger it is, the longer the wandering. The last to settle. And the cure is almost funny. Clip a small spring onto the dial itself, pulling it gently towards zero. The groove firms up. The wandering stops. That spring is ridge regression. Now the deepest choice on this wall. What if the nails are wrong sideways too? Everything so far rested on one quiet decision, the guide wires. They forced every band to pull straight down, which assumes only the heights of your nails are uncertain. Take the wires off. Let each band's bead slide freely along the rod. A frictionless bead can only rest where the band has no pull along the rod. So every band swings until it stands perpendicular. Its stretch is now the straight line distance to the rod. Same shelf, same letting go, but now it minimizes perpendicular error. Total least squares, the errors and variables fit. The line PCA would draw. Remember the mislocated satellites at the end of the shadow film. This is them. And a warning. With noise in X, ordinary least squares doesn't just wobble. It flattens, the slope shrinks toward zero. Choosing your error's direction is choosing your model. One more idea, and it's beautiful. Warm the shelf. Let it jiggle. Statistical physics keeps the books on a warm system. The chance of finding it in any pose falls off as e to the minus energy, divided by kt. And the exponential of a quadratic energy is exactly a bell curve, a Gaussian. So the least energy pose is the most likely pose. Least squares is maximum likelihood, falling straight out of heat. But listen to what the bands measure. Stretch. Only stretch. They never felt whether a nail was hammered in the right place. Least squares finds the best pose your shelf can strike. Not the truth. Bring the threads home. The nails were your data. The rod, your model, two dials. Each band, a residual, storing energy that grows as the square. The valley was the lost landscape, and letting go was gradient descent. Balance, force, and torque was the normal equations. Stiffness was trust. Constant tension was the median. The soft trough was a bad condition number, and a spring on the dial was ridge. And the guide wires were an assumption. Take them off, and the same shelf computes total least squares. 7 nails. 1 rod. All of least squares, hanging on a wall. So here it rests, in the evening. No search. No iterations. No one solving anything. A little energy shed. A little balance found. Let go, and the errors square themselves away. But look closely. It's never perfectly still. Leave it a little warm, and it keeps exploring. Every pose, visited in proportion to how good it is. What could you do with a machine that wanders like that? On purpose? That's a story for another day.